In the last few lectures, we worked so hard on setting up iterator support for our box container class, and we got it to a point where it even provides random access iterators, and that's really cool. In this lecture, we're going to try and use it with views and range adapters from the C++20 ranges library, and that's going to be really cool. That's going to work because now our box container class has iterators that were needed by these views and range adapters. So we have seen before that we can do something like this with stdiff vector. For example, we can set up a vector, we can set up a predicate as we see right here, and we can set up a filter view to filter things out. In this case, it's going to be filtering out even numbers, and we're going to be able to print them out. We can do something like this. Now, I want to show you that you can even replace stdiff vector here and use our own box container, and it is going to work really well. And this is a good testimony that we can now plug into the infrastructure provided by the C++ standard library. Try to think about what you would need to do to set up your own filter view if you didn't provide iterators to plug into the C++ standard library to be able to use a filter view directly like this. And a filter view is just 1 in 1,000 features that are provided by the STL, and providing iterators for your own collections is going to give you all that ability. You're going to be able to use all these features on your own collections, and this is really powerful. Okay, we can replace the vector for our box container, and this is going to work right away. Now that you know the idea, we're going to see a few of the other views you can play with. So you can set up your box container like this and use it as an input view. For example, here we have a predicate to filter out even numbers. We can filter events and we can print them out. We're going to see our output here. We can use a transform view just like we see here. And after we transform, we're going to be multiplying each element by 10. And if we print out our transformed view, we're going to see the new data. We can take a few elements from our collection using a take view just like you see here, and if we print out here, we're going to see our data. We can take while using a predicate, and if we print out, we're going to see our data here. We can drop a few elements from the collection using a drop view, and if we print out here, we're going to see the result. We can drop while, and if we print, we're going to see the result here. Nothing really complicated. We are just replacing our input collection to make it a box container. That's what we really want to do here. Here, I want you to see that we can even use range adapters. This is a range adapter we are using right here, and it is going to work. It is just going to filter out even numbers, and once we do that, we're going to print out our collection. We're going to see that right here. We can even print directly. This is going to work right away. We can even put a predicate right away in place. And we have our lambda function here, which is going to work pretty cool. And you can do all these things because our box container now supports the iterator needed by all these views and range adapters. And this is really cool. Another example I want you to see is that we can even use this on a struct. For example, we can set up a box container of students. We can add students as you see here. We can print these students using a range-based for loop. This is going to work. But we can even use a take while range adapter. So for example, we can do something like this. We can take students while the age is less than 15. We can do something like this. And we can print the students who meet this predicate here. This is going to work really well. Now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is custom iterators with views. This is what we're going to do here. Let's grab the code from the last lecture and use that as a starting point. I think that's going to save us a few seconds. Let's put in the code and crack this open in Visual Studio Code. This is going to give us our starting point. So let's crack open the main CPP file and let's take out whatever it is we don't need here. We're going to change our box container to call it VI because I think this is going to be our name now in the views and range adapters that we want to play with. Let's say VI. Okay, we have our data here. But before we do anything more, let's put in a function which is going to print our view. It's going to be a template function. Don't be mistaken by the auto keyword we have here, this is going to extend into a function template which is going to print anything. And those things that we print need to provide iterators that are needed by the range-based for loop that we are doing here. We are also going to go down and put in a structure that we're going to need a little later in the lecture here. The first thing we want to do is play with our filter view. Let's uncomment the things we need to play with here. So we have our predicate here, and we will try to print our view, our input view directly. We're going to print that out. But we are also going to set up a filter view, which is only going to filter out even numbers. After we do that, we're going to print out our filtered view, and this is going to give us our data. I think we need to include the ranges header for this to work. So let's do that. Include ranges. And now if we go down, I think this is going to work. Let's pass this through the compiler. We're going to use GCC, but you can use any of the compilers that support this feature. You see the build is good. We can bring out a terminal window and try to run this. Let's clear Plopoli and run Rooster. You're going to see that this is going to filter out even numbers. So we have 4, 8, and 6, and the rest are going to be discarded because we are only interested in filtering in even numbers. This is what we are doing here. We can even print even numbers on the fly, so we can do something like this. And we're going to put our view in here directly, and this is going to work. Let's pass this through the compiler again. So the build should be good. We can clear and run Rooster, and this is going to work. So this is an example of how you can use a filter view. And again, the message is that this is working with our custom container. And this is working because the container provides the iterators that are needed by these views and range adapters, and this is really cool. Let's go back to our main function, and I think we can comment out our filtering that we are doing here. The next thing I want you to see is that you can use a transform view on our collection, and this is going to work as well. Let's comment this out, and we're going to bring in a transform view. We're going to transform each element in our collection, and what we're going to do is multiply each instance by 10. Once we do that, we're going to have a transformed view. We're going to print this out, and we're going to see that the data has changed. Let's pass this through the compiler. We're going to use GCC as usual, so let's choose that here. The build is going to be good. Let's clear and run Rooster. We're going to see our input collection, and our transformed collection is going to be 50, 10, all the way to 60 here. And you're going to see that the transformation we do here has no effect on the original data. This is just going to give us another view which is transformed on the data, but the data in our input collection is kept intact. I really want you to keep this straight in your mind. Okay, let's comment this out, and we're going to look at the take view. To really give you as many examples as I can, let's put in the example here, and we're going to uncomment this. And we are just going to take 5 elements from the input collection. That's going to give us v taken here. We're going to print the input collection, and we're going to print v taken to see what we just took from our input collection. Let's pass this through the compiler. We're going to use GCC, the latest version I can get my hands on. Let's clear and run Rooster, and we're just going to take 5 elements from the collection, and that's going to be 1, 2, 3, 4, and 5, and that's what we have right here. We can also take while. Let's comment this out and show you that example. We're going to go down and put in that, and we're going to uncomment and make sure this is active. And all this is going to do is going to take while a predicate is made, and we're going to take as long as we have odd data. So we're going to have the input collection, and we're going to print v taken while, and we're going to see what we get. Let's pass this through the compiler. The build is going to be good. We can clear and run rooster. So we're going to take while we have even data, and that's going to be the 5 and 1. Once we hit the 4 here, we're going to see that it doesn't meet the predicate, and we're going to stop taking. And if we print v taken, we're going to see 5 and 1 here, and this is really cool. We can also drop data. Let's comment this out and show you that. We can clear and put in our new code. We're going to uncomment. Now we want to drop, and we're going to drop 5 elements from the start of the input collection, and we're going to be left with whatever is after these 5 elements here. This is what we can do with our drop view here. Let's pass this through the compiler. The build is good, so we can clear and run rooster. We're going to drop 5 elements, so we're going to drop 1, 2, 3, 4, and 5, and we're going to be left with 3, 7, 9, 6 here, and that's what we see printed out. This is really cool. We can also drop while. Again, these are the things we have seen in the chapter on the ranges library, but now the point is that we can use this with our own box container, which provides the needed iterators for this to work, and this is really cool. I want you to see as many examples as we can on this. So we are going to drop as long as a predicate is met, and we're going to drop as long as we have odd data. So we're going to drop the 5 and the 1, then we're going to grab whatever is after that. I think this is what we're going to get when we print this. Let's pass this through the compiler to be sure. We can use GCC, our favorite. Let's clear and run rooster, and you see that this is going to drop 5 and 1, and we're going to be left with 4 all the way to 6. This is really cool. The next thing I want you to see is that we can even use range adapters. Let's comment this out and say range adapters below here, and we're going to put in the code. I think we need to comment this. We need to remove the comments here, I should say. And the point of interest here is that we're not building a view like we did before. Look at the previous examples we did. We said std ranges drop while view. We built a view, but now we are going through a factory method which is going to manufacture a view for us. And this is a range adapter. This is how they call it in the C++ standard library. So we have a predicate here that is going to be used to filter things. And after we have this view, we're going to print this out, and we can do this directly and pass the data through the print method. And we can even use a random function directly in our print function. And this is going to work. I am just trying to give you as many variations as I can on this. Let's pass this through the compiler and make sure this is working. The build is good. We can clear and run rooster, and we're going to filter out even numbers, and you see that this is working. The last one is going to filter out odd numbers. That's why we have 5, 1, 5, 3, 7, 9. But this is really working now. And the idea is that we are using range adapters to make this work. And this is really cool. Let's comment this out. We're going to set up an example that uses our student struct. And that's going to be really cool. We're going to be able to filter out students whose age is less than 15. And using the pipe operator to do these things, this is going to be really cool. The first thing we're going to do is to set up our box container. Let's go down here and do that. So we're going to set up a box container containing students. And we're going to add in student data using the syntax here. And we're going to print whatever we have in our classroom here. Let's do this and see what we get. We can pass this through GCC. The build is good. We can clear and run rooster. So you're going to see that we're going to print the students in the order we put them in. We have Mike, John, Drake, and Mary. We can also sort these students, and after we sort, this is going to be using the three-way comparison operator that we have in our student struct. If we go back, we're going to see this operator here, and it is going to be used to generate the comparison operators needed to make our sorting algorithm work here. So we're going to be sorting based on the std less predicate. I think that's what we have here. Where is our sorting code? Okay, let's go back again and put in our sorting algorithm. So we are calling the sorting algorithm here, and this is going to work. Let's pass this through the compiler. The build is going to be good. We can clear and run rooster. After we sort, we're going to see that Mike is going to come first, Drake is going to come second, Mary is going to come third, and John is going to come fourth. And this is happening because we are specifying a projection according to which we are going to be sorting here. And this is really cool. Again, if you don't know about projections, please go back to the chapter where we learned about the C++20 ranges library. You're going to see all there is to know about projections. This is going to work. So we are sorting based on the age through our sorting algorithm here. And this is really cool. The other thing I want you to see is that we even have the ability to print students under a given age. We can do something like that if we want. So we're going to set up a view that filters out students less than 15. And we're going to use our input collection, which is classroom here. We're going to pipe that through a view that takes while a predicate is met. And our predicate is going to be true if the age is less than 15, and this is going to do what we want. Let's pass this through the compiler. I want you to see that this is going to work. So the build is good. We can clear and run rooster. You're going to see that students under 15, we're going to have Mike, who is 12, and Drake, who is 14. And another thing I want you to see is that we can even use a view composition. So that's what we're going to do right here. Let's comment out what we have here. And we're going to use a one-liner on top here, which is going to print things directly. So we're going to say std_view take while, and we're going to specify our predicate, and it is going to take while this predicate here is met. And this is going to do exactly the same thing as we did below here. But the pipe operator is much more common in projects out there. Let's pass this through the compiler, and you're going to see that this is going to work exactly as we expect. The build is good. We can clear and run rooster, and this is going to give us the same data. This is really all I wanted you to see in this lecture. Again, the main message is that our box container that we built ourselves is able to work with views and range adapters from the C++ standard library. And this is yet another example or proof that with the iterators that we set up, we are able to plug into the infrastructure provided by the C++ standard library. Again, think about what you would need to do to get all these views and range adapters work for your container. If you didn't go through these iterators, that would take you a lot of time to set up, and it wouldn't even be scalable. That wouldn't work with other containers, but we are able to use this because C++ is designed in a very clever way, taking into account many use cases, and this is really cool. We are going to stop here in this lecture. In the next one, we're going to learn about constant iterators. Go ahead and finish up here and meet me there.